Welcome to The Explainer, where we break down the big ideas that are shaping our world. And wow, do we have a big one today? We're going to talk about the origin story of modern AI. And believe it or not, it all comes back to a single research paper from 2017 that just turned everything on its head.
All right, so let's get right into it. Before this paper dropped, the AI world, especially when it came to language, was pretty much dominated by one type of architecture. The big players were these things called recurrent neural networks, or RNNs for short. And yeah, they were pretty powerful, but as you can see from this quote, they were also really complex. And buried in all that complexity was this huge fundamental flaw, one that was seriously holding everything back. To really get why what came next was such a revolution, you have to understand this one big problem. We're going to call it the sequential bottleneck. So think about an RNN reading a sentence. It had to look at the first word, kind of hold that thought, then look at the second word while still remembering the first, then the third, and so on. It was this slow, one-by-one process, like a chain. Right? And that one-at-a-time thing, it created this massive computational traffic jam. It wasn't a problem you could just solve by throwing more computers at it? The process itself was the bottleneck, and the longer the sentence, the worse that gridlock got. Okay, and this right here shows you the breakthrough in a nutshell. Look at the old way, the number of sequential operations that's O of n, it grows right along with the sentence length. So more words meant more steps, meant more waiting. But this new idea, self-attention, it's O of 1. That means it takes just one step. It doesn't matter if the sentence is 10 words or 1,000 words long. It's one single parallel leap, a total game changer. So this whole bottleneck thing really set the stage for something big. A group of researchers over at Google were looking at this hard limit, and they decided to ask a question that was, honestly, pretty radical. A question that was going to challenge the way everybody was thinking. They basically asked, what if we could just get rid of that whole sequential process, that slow, word-by-word conga line? What if a model could just look at the entire sentence all at once and just get it? Understand how all the words relate to each other in a single instant? And here's their answer. They proposed this new simple network architecture. They called it the transformer. And the key thing here, it was based solely on attention mechanisms. It completely dispensed with or, threw out that whole sequential process. It wasn't an improvement on the old way. It was a total demolition of it. Okay, so how on earth did they do that? Let's pop the hood and look inside the transformer. The secret sauce, the thing that makes this whole magic trick possible, is a mechanism called self-attention.
Yeah, I know, the definition sounds a little academic, but the idea behind it is actually pretty simple and elegant. For any given word the model is looking at, self-attention lets it look at every other word in that same sentence and figure out how much each of those other words matters to understanding the meaning of the first one.
Here's a great way to think about it. The librarian analogy. Imagine you have a question. That's your query. You give it to a super fast librarian who can instantly scan the titles of every single book in the library. Those are the keys. The librarian figures out which books are most relevant and then pulls the actual information, the values, from those books to give you an answer. Now imagine the transformer doing that for every single word in a sentence, all at the exact same time.
And get this, they didn't even stop there. They took it a step further with something called multi-head attention. So instead of one of those super librarians, imagine having 8 of them working in parallel. Maybe one is a grammar expert. Another's job is just to figure out what it or they refers to. A third is looking at the overall tone. They're all focusing on different things, and then they bring all that information together. The result? A way richer, deeper understanding of the text, all happening simultaneously.
So, okay, this all sounds amazing in theory, right? It's faster, it's more efficient, it's a totally new way to think about language. But did it actually work, like in the real world? That's the million-dollar question. Oh, it worked. It didn't just work, it completely shattered the existing records. So on a really common benchmark for machine translation, they got a score of 28.4. Now, I know that number by itself doesn't mean much to most of us, but trust me, in the world of AI research, that was a huge jump, a massive leap forward. And this table really puts that victory into perspective. I mean, look at this. The transformer isn't just a little bit better, it completely blows past the competition. And we're talking about complex models, ensembles, that were basically teams of other models all working together. The transformer beat them all. And here's the best part. It did it while being way more efficient and faster to train. It was better and cheaper. You can't beat that.
So this wasn't just, another small step forward. This was a seismic shift. It fundamentally changed the blueprint for how we build AI. And the legacy of that shift, well, it's literally all around us today.
So let's just recap the Transformer's big advantages. First, because it's so parallelizable, it could finally take full advantage of modern computer hardware. Second, because it could see everything at once, it had a much easier time connecting the dots between words that were far apart, something old RNNs really struggled with. And the result of all that? It just produced superior quality. It set a whole new bar for what AI could do.
And really, here's the punchline to this whole story. That architecture, the one laid out in this one paper back in 2017, it's the foundational blueprint for pretty much all modern large language models. Yeah, I'm talking about things like ChatGPT. Every single time you use one of these incredible AI tools, you're interacting with a direct descendant of the Transformer.
So by finally breaking that sequential bottleneck, this paper gave AI a superpower, the ability to understand context instantly, all at once. And that single change is what unleashed the entire AI revolution that we're living through right now. Which really just leaves us with one big question to chew on for the future.